ఇప్పుడు వీడియో పనిచేసి ఏమంటా
नमस्कार ओझा साहब, नमस्कार ओझा साहब, नमस्कार। अनम्यूट करिए ना।
जी कर दिया सर। बहुत बहुत नमस्कार।
बहुत बहुत नमस्कार। अब कैसा है?
अच्छे बढ़िया शिवराम साहब, बहुत आशीर्वाद आपका। खुश।
नहीं, भगवान का आशीर्वाद है साहब। बहुत दिन के बाद अब देख रहा है आपको।
हाँ, बहुत दिन के, काफी टाइम के बाद।
जी जी जी।
और क्या प्रोग्राम है साहब? अब क्या प्रोग्राम बन रहा है? हो गए चुनाव?
नहीं, चुनाव का कुछ नहीं है। बस चुनाव हम क्या करते हैं, नहीं है सर। ऐसा है हमारा छोटा मोटा इधर उधर क्लासेस रहता है ना,
जी जी
ट्रेनिंग क्लासेस रहता है, चलते रहता है।
जी
हमारा
जी।
एनआरडी में रहता है अभी क्या है
Sir, request you to not to use this public platform for personal
Okay,
message.
yeah, we are
ओके
sorry.
सर, ओके, सॉरी
After a long
सर।
time I am seeing, that's why. Thank you. Yeah.
ओके ओके सर।
Sir, good evening, sir, from Jal Jeevan Mission, Tamil Nadu. Is it audible?
You are audible.
Yes, it is audible.
Thank you, sir.
Good evening, sir. From Telangana. We are all
Yes, ma'am. Yes, ma'am. You are audible.
I used to dance for Telangana.
Soen sir, are you available on the site right now, or still the meeting going on that you will be joining after 5-6 minutes? Hello. Soen sir, are you available on the online? Am I audible?
Yes, audible. Please go ahead. I am available here.
Okay, thank you, sir.
I am audible or not?
Yes, sir, you are audible.
Yes, sir, you are audible.
Shall I start or you give us some introductory?
Actually, Soen sir will be little bit, busy right now. He will be joining shortly. The moment he joins, then we will start. Just bear with us for time being for 5-6 minutes.
I'm audible, bola.
Okay, sir. Soen sir, shall we start, sir? Soen sir, shall we start?
Yes, now we'll start.
Okay. Saikia sir, advisor sir had joined already?
Wait. Please wait for a minute, please.
We'll wait for a minute.
અહીંયા બંધ કરજો.
As we are waiting for our advisor, sir, just he's finding some difficulty in getting the link. Just for a moment, please.
Good afternoon, Sekhe sir. I have joined.
Okay. Advisor sir has joined. So please, Arup, you can start. Swain sir, can you
Okay.
start the session? Swain
Yes.
sir? Okay. Thank you very much.
Okay,
Mr. Arup.
okay. We'll start. Muralidharan sir, Niti Aayog, sir, Namaskar sir. It's nice to see you that you have joined as you have there in the Jal Jeevan mission for long term. Thank you, sir, for joining us.
Yeah, thank you, Kansa. Thank you so much.
Okay. Now I'll start the session. Our advisor of our National Institute of Water and Sanitation, SPM NIWAS, had also joined, and then our sector head, Mr. Saikia, also joined, and then Swine Sahab also joined. We'll start the program. Actually, I'll just give you a brief background on this. SPM NIWAS has initiated an outreach effort to organize a series of webinar series. So we have done couple of webinars. This is the fourth one of this series. We had two this is the fifth one, I say. Two we had in the water and two we had the SBM sector. Now this is the fifth one. This is a very interesting project, and we are also including almost all the like-minded training programs that as a vertical of capacity building. This is one of the session. It is basically the directly drink from the tap initiative by Watco. We are happy that today Mr. Pradipta Kumar Soen sir, Chief Executive Officer, Watco, Water Company of Odisha, is amongst us to give us his insight on the directly drink from the top tap in ISI 10500, top quality 24/7 water supply system. He is implementing this program in 8 cities, and now those cities are Puri, Nimapur, Gopalpur, Berhampur, Rajgangapur, Rainagar, Champua, and Bremitapur. Now, what is another 16 cities is going on, and Bhubaneswar is almost in the completion. Today amongst us, Mr. Pradip Kumar Swain, he has a nearly 4 decade of experience in the water sector. At present, he is working as a chief executive officer. Basically, by profession, he is a civil engineer, and he is, one of the architect of the drink from the tap mission of government of Odisha. And under his leadership, this is a mission mode project is implemented by the Odisha government. Before I hand over the stage to Pradipta sir, I would request advisor sir to briefly introduce our institute and our activities. Advisor sir, please.
Arupji, I think Sekya sir also want to say a few words. Sekya sir, please.
Okay, Sekya sir, please.
Good afternoon to all and very hearty welcome from SPM NIWAS. It is our constant endeavor to disseminate all the good practices of different states through this platform. So, as Mr. Khan has already mentioned, and this subject is very interesting and very pertinent to Jal Jeevan Mission, as it speaks about drink from tap. And this is really a very, very, very interesting subject. And as a member of the National Task Force, Swain sir has already advocating that all states of the country should adopt this initiative. And we are planning this webinar in 2 parts. In the first part, where Swain sir will present his presentation, and I request all the participants kindly to switch off their microphone, and his presentation should not be interrupted in between. And after Swain sir completes his presentation, we shall formally announce a question and answer session, a brief session, of course. Nobody should go for a very long question. We should complete it by 1.5 hours. So please, before putting any question, please raise your hand electronically. I think from this session, we all will be benefited. Now over to our advisor, sir, please.
So, good afternoon, Shri Pradip Kumar Swain sir. First of all, I am thankful to you that you have spared your valuable time to share your success story, that is drink from tap, for the entire country. So this is in a webinar series as explained by Mr. Arup and Shri Sekya, that we want to disseminate the good work being done by the various stakeholders in the country, so that from their work others also get benefited. So today's lecture is very, very important, as already highlighted by Mr. Sekya. Drink from tap is very, very important. Right now, in the entire country, people are suffering because they say people are not ready to pay for water, people are wasting water, people are not taking connections, then they are designing a lot of IC activities. But what we understand is that if you are supplying them a quality water, reliable water supply, preferably 24/7, if not, then down-to-dusk water supply, at good pressure, equitable pressure, and at least having 0.2 ppm residual chlorine at the doorstep of the consumer, then we can definitely ensure that the consumer will start using our water. And drink from tap is more important, because otherwise what is the practice is that normally from the municipal water supply or panchayat water supply or a rural water supply scheme, people take the water, then they install their own secondary source of treatment. Few are installing RO plants, other are installing simple units where they are using some treatment systems to kill the bacteria and pathogens, and then they are using that water. So people are not really convinced about the quality of our water. But the initiative by the WATCO is the first step in the country, where they have with confidence said at the historical and religious town of Puri that people can drink water from tap. Their resource person came here, I think data administrator, I just forgot his name. He very well presented the story at the SPM NIWAS with the various training participants about how they have achieved a drink from tap. So that's what we felt it's very important that we should share it to the larger audience through this webinar. So with these words, I will not take much time, and I will request, as Mr. Sigi has also requested to everyone, that please keep your mic mutes, because if you are unmuting your mic in between, then you are disturbing the resource person, the person who is delivering the lecture, and we take much more time, and many people are not able to get the benefit of that lecture also. In fact, I will request the administrator also to mute the rest of participants. Once the session is over, then we can allow all the participants to unmute the mic and ask a question to the resource person. But right now, I will request the JJM team who's conducting who's the admin for this webinar. Please mute all the participants except for the source person and myself and Sekia Sahab and Anup. So rest should be muted. Once the lecture is over, then we can then give the option them to unmute itself. So I'm not taking much time. I'm handing over the mic again to the Sohan sir and I request him to present his success story.
Thank you. Good afternoon to everybody. So it is my pleasure to present the success story of drink pump tap in Odisha, pioneered by Water Corporation of Odisha. Actually, I have a meeting with Chief Secretary at 5:30. So I have to conclude this by 5:15. So I will take 1 hour and then 15 minutes for question answer. I should have taken more time, but Chief Secretary has arranged a meeting at 5:30. Anyway, as I think the audience before me are all engineers. So engineers from water supply sector, water authorities. So engineers of, am I audible or not?
You are audible, sir. You are audible, sir.
So the prime responsibility of the engineers of water authorities to provide safe drinking water. So not only drinking, safe drinking water, which is potable, which will not create or will not spread any waterborne diseases. So to prevent waterborne diseases is the prime responsibility of the engineers of water authorities, and that can only be achieved if we provide safe drinking water conforming to IS 10,500. So why we go for drink pump tap, or why should you go for 24/7? So that question now to be answered, because we are providing intermediate water supply. We are conducting quality tests at WTP level, at also zonal reservoir level. But we have no control in the network system. You see, a network system is prone to leakages. It is an electromagnetic system which is prone to the leakages. No network system in the world, pipe network system in the world, is 100% leak proof. The percentage of leakages, percentage of NRW may vary, but there are leakages. Israel is claiming it is 80% NRW. Singapore is claiming 6% NRW. Tokyo is claiming 4% NRW. Other countries, the Manila water supply is claiming to have 12% NRW. But nobody has claimed the zero NRW. So that means there is leakages, less or more. And in Indian scenario, it was 15% in the distribution system earlier and 5% in rising mains and WTP. Now in the revised manual, which has been published in December 23, it has been reduced to 5% in rising mains and WTP and 10% in the distribution network. So that means we have to limit our NRW to 10%. That means there are leakages. A network system to me is full of holes and joints. If you use DI pipe with standard length of 5.5 meter, in a city if you use 500 kilometers of pipe, you see enormous quantity of joints. And if in a city there are 50,000 households, You have to give connection to 50,000 houses, 50,000 holes. We are rupturing the pipes, inserting the ferrule and giving connection. That means we are deliberately making holes. So these holes and joints are prone to leakages. And in intermittent water supply, when water flows through the pipe in pressure, so water leakages through these holes and joints. And when water goes out of the pipe's line, then it accumulates in the outside of the pipe. In intermittent water supply, what happens when the water supply is stopped? The negative pressure is developed in the pipe. Vacuum develops in the pipeline. So whatever water was gone outside by leakages again re-enters to the pipeline. And when that water re-enters to the pipeline, so it comes with pollutants, comes contaminated. And the next shift of water supply, it goes to the consumer end. So in intermediate water supply, we cannot guarantee the quality. But if you go for 24/7 water supply, what happens? If there are leakages, the leakages are always from the inside of the pipe to the outside of the pipe. So whatever water goes through leakages never returns back, comes back to the pipe again. That means the contamination, chance of contamination is eliminated. Therefore, to ensure quality, 24/7 water supply is a mandatory requirement nowadays. And DFT is an upgraded version of 24/7 water supply. 24/7 water supply is a mandatory component of DFT. So you first convert to 24/7 water supply, then you add some features to 24/7 water supply for rigorous quality monitoring. So then only we can confirm or we can assure that it is conforming to IS 10500. So this is all about the DFT. So in 2019, we started this mission. The drink from tap mission was constituted, where my additional chief secretary G. Mathivathan Sir was the chairperson of the mission, and I am the mission director. So till now, that mission is continuing, and I am the director of drink from tap mission. Under this drink from tap mission, so we first pioneered few small pilot zones. Before pilots, we took a sub-pilot zone, having only small houses, a few number of houses, 500 houses in Ishantar Basti, Bhubaneswar. So we learned a lot. If I narrate my experiences, only a lot of time will be killed. So we learned from that sub-pilot zone, and then accelerated it to 12 pilot zones in Bhubaneswar and 8 pilot zones in Puri. So after successful completion of the sub-pilot and then pilot, then we converted the entire Puri town to DFT, 24/7 water supply. So Puri became the first city to have DFT entirely in the city level. Then after Puri, we have completed 7 other cities. So 8 cities in Odisha have been completed with DFT till now, and work is under progress in 16 cities. A total 24 cities. Out of 414 DMAs, we have already completed 274 DMAs, and all other DMAs will be completed. I hope within coming 6 months, all these 24 cities will be converted to 24/7 water supply. So, what to be done? How to convert? How to switch over from this intermediate water supply to 24/7 water supply or DFT is a big question. So, it is mandatory that for eradication of waterborne diseases, for upkeeping of the health of the public, because we are all public health engineers, because we deal with the preventive part of the health. And when we fail, when waterborne diseases break out, outbreaks, then the doctors come. So our duty is to prevent that. So for prevention, this 24/7 DFT is mandatory. That is why we should go for DFT. This is my answer. And how? You see, we are now comfortable with intermediate water supply. I cannot say that you remove all the pipelines, everything, whatever you have with the intermediate supply and go for new infrastructures. That is not also possible on part of any state or any water authority. So that means we have to convert the present system, the present water supply system to 24/7 DFT. So how to do it? There are two basic necessities for implementation of 24/7 water supply. One is you have to adhere to the specification. Second, you have to follow precision. These are two guru mantras you have to follow: specification and precision. Unless you follow specifications, you have to face the logic. If you don't do the house service connection perfectly, so there will be leakages at a fuel point. If you don't lay the pipelines as per the specifications, there will be leakages and joints. And while the implementation, we have to face music. Therefore, specification is very important. In intermediate water supply, you may not give such importance to specification, but when you are converting to 24/7 water supply, specification must be adhered to. Then adoption of technology for precision. How you achieve precision? That means you have to adopt technology, adequate technology, proper technology. So one by one, I will discuss the brief principle for technologies which are required for DFT, and then if time permits, I will give a small presentation, because ordinarily my presentation takes 2 hours, but today my chief secretary has kept a meeting, so I have to go there, so I have to complete it within 1 hour. So first you see, I have gone throughout the country, wherever this workshop has been organized by CPHU or this National Task Force have organized the regional workshops. I have attended all workshops and I have given my speech there, and I have interacted with all the engineers of various states. The thing is that the network system is not known to our engineers, not known to us. We are not conversant with the present network system. That is the whole problem. The pipeline has been laid over the years. The engineers have been transferred regularly. So nobody knows what are the pipelines, whether it is PVC or it is DIE or it is CIE, the material of a pipe, the diameter of pipe, in which side this pipe has gone, whether in the left side of the road or right side of the road or at both sides of the road. So this system is not known to anybody. Also very critical is that valve position. Where is the operating valve? Which valve is being regularly operated? Which are being partially or temporarily operated? So all these things is not known to us. So when you don't know, then how to approach? That is a big question. You see, there is a saying, knowing is half doing. If you know, half of your task is done. If you do not know, so you cannot start also. So you have to know the system. Knowing is most important. Knowing the system. So for knowing what to do, we do not know. No systematic record is available. So your predecessor has not given all the records. Whatever available records or drawing is available, network drawing is available. You cannot guarantee that that is 100% correct. So correctness is in question. So we have to know first. And for knowing, the only thing is we have to map it. The assets have to be mapped. So asset mapping is an essential technological intervention for DFT. This is the first step. You have to map the assets. Assets means pipelines, valves, and special fittings, pumping stations, pumps, storage reservoirs, everything is to be mapped correctly as per the ground survey. Ground truthing is to be done by asset mapping. Once that mapping is over, that should be validated also. Not mapping, it should be validated. And after validation and asset mapping, it should be kept in the GIS platform. Why? If you keep it in geographical information system, it is saved. Because it is not in GIS, now we are confused. So therefore, it should be kept in GIS first. And if you place it in GIS, if you implement smart water management later on, so it will be helpful for O&M. So asset mapping and putting it into GIS platform is a mandatory requirement of DFT. Then consumer mapping. We do not know also exactly the consumers. How many consumers, how many customers are there in a particular lane by lane, we do not know. While a DPR is prepared, it is prepared on assumption basis. That means there are so many methods, arithmetical, geometrical, incremental method, or decadal growth method. So whatever you do, so this is the growth of a decade. You take 2011 census. After that, no census has been prepared till now. Then you apply the decadal growth method and get the total population. But total population is okay for preparation of the DPR, but this will not hold for 24/7 because we have to know how many consumers are there in a particular lane or by lane, and what should be the quantum of water in that lane or by lane to know the sizing of the pipeline. So then consumer mapping is essential. So one technological intervention is asset mapping, second is consumer mapping. And after consumer mapping, so condition assessment is the third technological intervention. So what is the condition of the present network system is to be known. That is very important. So for condition assessment, there are so many procedures. So for condition assessment, you can use robotic camera, you can cut it physically and see. Other methods are there. You can, for locating the pipelines, you can use pipe locators, you can use ground penetration radars also. All these instruments are there, equipments are there, by which we can know, we can map the assets, we can know the condition. So after the condition assessment, we can say that which pipeline is to be replaced, which pipeline is to be kept, not to be replaced. So that will be decided. So condition assessment, network mapping, then consumer mapping, then condition assessment. After that, so we will isolate. We will go for DMA-wise approach. In 24/7 water supply, district meter area known as district meter, that is to be isolated. A city is to be divided into many cities. In Bhubaneswar city, so we have 137 DMAs. That means Bhubaneswar city has been divided into 137 district meter areas. The water from one DMA to other DMA is not allowed. So totally isolated, hydrologically district. So inflow of water from one DMA to other DMA is not allowed, or from the city distribution system is not allowed. So that is to be isolated. Not only isolation of the DMA, isolation within the DMA is also very much essential. Why? We know that for years together, since last 50, 60 years, so pipeline is being laid. And the concept was that when there is some inadequate pressure at the tail end, so we joined a pipeline from this line to that line to make a loop. There was a idea in the mind of the public health engineers that you make a loop, the pressure will increase, they will get water. So there are n number of loops in a DM also. So in 24/7 water supply, this loop system is not permissible. All the network within the DMA should be dead-end system. It is a tree-like structure. So main branch line, then sub branch line, main line, so all are dead at the end. So isolation within the DMA is also important, so that all ends are dead ends. So after making isolation of the DMA and within the DMA, we have to go for hydraulic modeling, network hydraulic modeling. So network hydraulic modeling is done DMA wise. So if Bhubaneswar city has 137 DMA, that means 137 hydraulic modelings for all 137 DMAs. So hydraulic modeling is done by a software known as WaterGen, because previously this was being done by EPANET, but the better version is WaterGen, which can take care of the friction loss of the valve also, which EPANET cannot take. So that software, we use that software to have hydraulic network modeling. By network modeling, we have to ensure the minimum residual pressure at the tail end. You see, previously in the manual, 17 meters was prescribed to be the minimum residual pressure for 3-story building. But nowadays, in the new manual which came up in December 23, it has been recommended that you keep the minimum residual pressure 21 meters. So we follow the new manual. So 21 meters of residual head to be maintained at the tail end of the DMA. So accordingly, this network modeling is done. So after network modeling, so we can find out what is the residual pressure at what points and what is the head required from the reservoir. What should be the staging height of the ESR if it is governed to the ESR. Water supply can be affected to the DMA from an ESR by gravity. The ESR should be filled up directly from the rising main or may be filled up from the underground reservoir there. So that is one possibility. So water can be fed to the DMA from the underground reservoir itself by direct pumping also. There is no problem. If there is no scope of construction of ESR or combination of both, because storage capacity is important. As per the recommendation of the Government of India, because this whatever guidelines of DFT has been issued by the Government of India, so first they discussed with us and accordingly the guideline has been prepared. So the storage capacity is generally derived from the mass curve as described in the CPHO manual. But on an average, Government of India has issued guidelines that the storage capacity should be 1/3 of the day's consumption. What is the total consumption of the day? 1/3 for the storage capacity. So it may be one ESR, maybe one user, one ESR, or maybe one user also, no problem. So the head there, if it is ESR, staging height can be determined. If not ESR, the pump, head of the pump can be determined from the network modeling. So if you go for those, your hydraulic modeling is done. Height of the ESR is finalized, or head of the pump is finalized, everything finalized, diameter is finalized. So now you are ready for go for tenders. So your estimate is prepared accordingly and go for tenders and execute the work. So while executing, you have to follow the specification. Then you come to the precision. So for precision, why precision is required and how to achieve that is an important. Just I am talking common factors of DFT. So precision means, you see, in a 24/7 supply, your network should be charged 24 hours. There should be no negative pressure in the network. charging of network at the downstream of this storage reservoir 24 hours is mandatory. So how it will be done? So that means feeding to the network as and when required is mandatory, either by pumping or through from the ESR. Whenever the network becomes, suppose you give a philosophy, a logic that I have to maintain 17 meter of residual pressure. So when that residual pressure recedes due to consumption, so continuous filling should be there from the ESR or from the user, from zonal reservoir. So that means your network system should have a communication system with the zonal reservoir. Network system should communicate. Now my pressure has dropped, so from the required design pressure, so you feed me. So the zonal reservoir should feed. And for feeding of zonal reservoir, the zonal reservoir should have adequate water. If it is in ESR, the level should be maintained at it. There should be a minimum level and a maximum level. So minimum level should be maintained always, or else you cannot feed to the network. And when the minimum level is reached, then immediately the filling of the ESR is required, or a filling of the user is also required from the rising mains, which comes from the WTP. So that means the rising main which comes from the WTP and feeds to the zonal reservoirs should maintain a continuous constant pressure. In Puri, we are maintaining 4.2 kg. In Berhampur, we are maintaining 3.2 kg. And Bhubaneswar, we are maintaining 8.5 kg. So, you see, so for that, for maintaining that pressure, precision instruments are required. And when that pressure drops, then the rising main also should communicate to your water treatment plant or the CWR pump out or WTP. So that should be pumping. And when the level of the CWR at the treatment plant recedes and the feeding is required, then it should communicate to the intake well, so that intake well will feed to the WTP. So there should be a seamless communication between the distribution network and the zonal reservoir to rising main to WTP, and WTP the intake. This seamless communication can be done only by using precision instruments. One thing I am telling, for level you can use level sensors. For pressure you can use pressure sensors. So measuring the flow, we can use flow meters, electromagnetic flow meters, smart flow meters. So then all these signals, the pressure or level, should come to the PLC, a programmable logic control panel, PLC. So it gets the signal and gives the command. The PLC gives the command to the pump to run. The PLC gives the command for the reservoir to be filled up. So PLC is one of the most important component of this WTP. One PLC, at least one PLC in one DMA, apart from street side PLC, if it is required. One DMA also can be divided into several sub DMAs depending on the level difference of the area and the type of infrastructure available in the area. If the ground gradient varies more than 6 meters, then a sub-DMA, new sub-DMA is to be created to ensure adequate pressure at the land. If in some areas the infrastructure is high-rising buildings within the DMA, and the other side there are slums or single-story buildings, so separate feeders could be laid, or else the low discharge will be at the low ends and high-rising buildings will not get any water. So this is known as dividing the DMAs into sub-DMAs. Sub-DMA concept. One DMA can have 5, 6, 7 sub-DMAs, 8 sometimes, no problem. ideally, the government of India has issued guidelines that one DMA should have 500 to 3,000 connections, but it may vary, maybe more, maybe less, depending on the design criteria. And sub DMA, it should be divided. It should be decided on the reality, ground reality, level difference, and type of infrastructures. So these flow meters and level sensors, level indicators, and also you see quality is the main criteria in DFT. We are assuring the people to drink from the tap. That means I am assuring the people to drink from the tap. I am taking the guarantee, because people will not have their own storage. They have to eradicate all the swamps, overhead tanks, everything. No aquaguard is required. No filter is required. No secondary treatment is required. So I am assuring people, you drink. I am giving potable water, conferring twice 10,000, you drink it. So that means I must be very much extra conscious of over the quality. So if there is any problem in the quality, then I am nowhere. So I have to take extraction. What is that extraction? So I should have a chlorine injection system at each storage reservoir level. We are adding chlorine at the WTP level, and then it is coming to the storage reservoir. And also we have facility to add chlorine at the storage reservoir. But ensuring at the tap point of the consumer is more important, because we have to maintain 0.2 ppm residual chlorine at the tap point of the farthest consumer. So if that is not maintained, we are failing. So for that, a chlorine analyzer is to be installed, another 1, 2, 3 as per the requirement at the DMA level, at the farthest point. So that chlorine analyzer senses the chlorine. So if it is less than 0.2 ppm, a signal comes to the PLC. PLC gives the command to the chlorine dosing unit there installed. So automatic chlorine dosing starts. So when it becomes 0.5 ppm, so again a signal comes, so dosing stops. So this chlorine, automating chlorine dosing and analyzing the chlorine at the farthest point of the DMA is the most important. Apart from that, you see, a concept, when we are loading the ESR, so we cannot open the valve always, it should be automatic. So we use altitude pilot control valves. That means no electric actuator is not required. So by hydraulic differential pressure, it opens and stops. When the minimum level comes, it opens. When the maximum level reaches, it stops. So altitude control valve is a precision instrument. And another beautiful precision instrument known as flow control valves, is installed at the DMA level and sub-DMA level. That means, you see, the consumption pattern is not same throughout the day. Sometimes in peak hours, peak flow is required. Normal flow is required at some time. And also midnight, 12 to 4, it may not be required any flow, midnight flow, very less. Only the pipeline is to be charged, not to develop negative pressure. So depending on the behavioral pattern of the consumer, so we can program, we can vary the pressure. We can regulate the pressure and the flow by this control valve, so that our NRW is reduced. You see, a concept, the people think that 24/7 water supply, 24/7 leakages, so leakages will be more, so NRW will be enormous. So how can we reduce the NRW? As a matter of fact, all the 9 parameters of SLB can only be achieved by providing 24/7 supply. And NRW and quality are 2 important parameters. So installation of water meters, consumer water meters, is mandatory. installation of bi-lane water meters. In each lane, a water meter is fixed. So you know how many, I have done consumer mapping. I know how many consumers are there in that lane. So what should be the flow? If I take the meter reading at that lane point, I can know what should be the flow. I can take the consumer meter reading of those 50, 60, 100, whatever houses in that lane. So I can compare, I can see where is the losses. So for water audit system, for water auditing and consumption of NRW, the installation of bi-lane water meter may be pulse type mechanical with a pulse output system. So to be installed at the inlet point of the lane or bi-lane. And consumer water meters, I don't know, we are using multi-jet mechanical water meters. So others are suggesting for smart water meters. We have not gone due to the cost, but we are using multi-jet water meters. So this is important. So these are the precision instruments. So the sound is coming. Please, somebody, sound is coming. Please, somebody, please mute. Sound is coming.
Please mute your microphone, Mr. Neeraj. Please mute your microphone.
So,
Please, sir, continue, sir.
So by use of these precision instruments, as I told, this level sensors, pressure sensors, flow meters, control valves, then chlorine analyzers, then lane water meters and lane level water meters. So these are the precision instruments. By using, we can adhere to the precision and we can achieve the SLB parameters. So adhere to the specification, adhere to the precision by using precision instruments. And one beauty of that flow control valve, I may tell here, that if something happens at the downstream of the control valve, so pipe bursts, then the desired, the flow is more than the desired quantity, the control valve automatically stops. So that your you save water. NRW is saved. That is the beauty of the control valve. Then we have adopted here a JALSA, the community partnership model. JALSA is they not this grievance, they address the grievances of the public, collect the grievances of the public, bring to us. We have 24/7 water supply, 24/7 IVRS system. We have 24/7 call center, because customer satisfaction is the most important in DFT. We will claim that we are giving 24/7 water supply, DFT water supply is my customer is not satisfied. Ultimately, the consumers are not satisfied. So only I will tell that I am giving good quality of water. That does not hold any meaning. Therefore, customer satisfaction is the motto of DFT. So we have engaged these community partners, self-help group members, women self-help group members, to know what is the problems. So one, what is the problem with the customers? One Jalsati has given an area consisting of about 700 to 800 connections. So that girl or lady is a member of that locality, maybe a daughter or daughter-in-law of somebody. She knows everybody, everybody knows her. So everybody can ventilate the complaints to them, the grievances to her, and we can know the grievances. Apart from our own system, 24/7 call center or IIR system, whatever we have. Apart from that, this is an additional thing. So consumer grievances redressal is one of the most important factors of DFT. And we have lab on wheels. So lab on wheels. So if anything at any means, any complaint comes regarding the quality, the lab on wheels will immediately rush to the spot and have the quality check at the doorstep of the consumer. And we have quick response teams. Anything happens, the 24-hour, 24/7 quick response team is ready. So they will rush to the spot and attend the complaint. So this will build the public belief. You see, believing is more important. The customer should believe you. There should be a relationship between yourself and the customer. Or else this 24/7 supply you can execute, but it is not sustainable. Unless the customers believe you, this cannot be sustainable model. For having a sustainable model, there should be a relationship built. A relationship will be built with you, the customers, with the consumers. And these are the engaging community partners, having lab on wheels, having quick response team. All these things are the instruments for confidence building, apart from IC activities, here for your campaign, everything. So apart from that, these are the instruments for building public confidence. You see, when there is intermediate water supply, you see there are storage tanks, and people suck water by pump, through pumps. So in 21st water supply, that is not allowed sucking through pumps. So that they should stop sucking, or they should dismantle the pump which has been installed, which is directly sucking from the pipe. So unless they believe you, why should they abandon that? So believe me. So this process of confidence building is also one of the major activities of sustainable DFT model. So all these activities, so there are so many challenges also. There are challenges, issues which are to be faced during the construction. So I will give a small presentation, time is running out. So I should have talked more, but no time is there to just go to the presentation. If I can skip the presentation, you see, is my presentation is visible? To share this. So is it visible? Is it visible?
Yes, sir, it is visible, sir.
Visible, sir.
Okay. You see the next. You see this scenario. Drinking water challenges in 16 and 17 in Odisha. You see, only 30% of the urban areas had pipeline network. Where from we have started our journey, I am telling. Then only 30% houses had tap connections. This deficit in water supply was 157 MLD. Low pressure, erratic and intermediate water supply. Disparity in water supply, water availability between cities and within the cities was one of the factors. Absence of metering, low revenue connection, and water loss was about 54%. And it is almost in all cities in India where intermediate water supply is now in force. No community connect was there. Water quality contamination, waterborne diseases outbreaks was predominant. Next. Then we have to change our vision. So we thought that directly drinkable water from tap 24/7 at every home with 100% metered house connection in a sustainable manner. That was our vision. So for that, we have to lay. We thought that if you go for 24/7 water supply, first people should get water. Then you go for 24/7 water supply. That means all houses should be covered. Universal coverage should be attained. 100% coverage should be attained. So that for that we laid about pipe network, about 6,500 or more than that kilometer of pipelines was laid, and at present it is 108 out of 115 ULBs have 100% pipe work, and 57 ULBs are left, which will be completed within 2 months. And last mile connections, you see, 99% households have pipe water connection, 97% of slum households have connections, and 105, this is not 105, this is 107 out of 115 cities have 100% household connection at present. Metering, you see, the metering we started in 2019, it was 0. Now it is almost 80%, not 70%. So Bhubaneswar became the India's first city to have 100% house connections in October 20 and 100% meter in March 23. Drink from 24/7 drink from tap conforming to IS 10,500 water supply in Puri was done in July 2021. So total 8 cities have DFT now, partially completed in 16 more cities, not 17. So 25, not 27 lakh population benefited till now. So substantially eliminated waterborne diseases, no casualty for 3 years. This is the result. So Odisha becomes India's first state to drink from tap water straight from the tap. So then next, enabling policy measures. So we had to change the policy measures. Previously, price procurement was not allowed. Directly, departmental price procurement was not allowed in Odisha. So, however, we changed the policy and the departmental price procurement was allowed by the government. Then we thought citizens have right to tap water. You cannot deny any citizen to have drinking water. And then for that, every house should be given a tap. And therefore, simplification of application process. You see, in many of the states now also, the process is very complicated. So many documents are required for giving a water supply connection. Previously also, we are demanding about 14 documents for approving a water supply connections. We eliminated everything on government approval, reduced the document to 2 only. One is ID proof, maybe Aadhaar card, and another is indemnity bond. Identifying that this water supply connection does not confirm any right over the land. So this much we took and gave connection. Waiver of connection fees urban port. You see, the DFT is a pro-urban policy, pro-urban flagship program of the government. So we waived completely the connection fee for the urban poor. Then easy installment of connection fee for others. That means connection fee, you see, previously the connection was being given, was being taken by the consumers themselves. We were approving, they were taking. That means they were engaging their plumber. They were procuring materials. Everything was being done by them. This same practice might have been followed now also in many states. But what happens? They engage third grade plumbers. They engage low quality materials, which give problem in future. So we cannot assure quality of water. Therefore, we took over. That means we have to give connection to them. And whatever cost is there, so we recover them in easy installment of 1,100 rupees per month, along with the water charges bills. That means from the pipeline to the meter, it is our responsibility. Then execution of house connection responsibility shifted from the consumers to the government. Exempting public from getting road cutting permission from municipalities, associated fees, which is around 10 to 15,000. Doorstep services, hassle-free connection process, training, certification, and empowerment of plumbers for leak-proof connection. Then community partnership involved women SSG in connection drive, camp approach at ward level and beyond for getting universal coverage. The next, you see the Jal Sathis. These are our community partners. About 947 Jal Sathis are trained and equipped for providing doorstep service across the state. Each Jal Sathis is earning an average of 15 to 20,000 rupees per month. Performance-linked incentive-based partnership act as a bridge between water supply agency and the consumers. So they are our face, the face of the water providers. If they ventilate us, we know the customers better through them. The role of the Jal Sathis is that they facilitate new connections. They get 100 rupees per connections. They facilitate in regularizing unauthorized connections, get 100 rupees per connection. New domestic connections, they get 200 connections. Meter reading and generating bills and collecting water user charges, get 5% of the revenue collected, not 5%, it has been enhanced to 7.5%. Field water quality testing, they get 20 rupees per test. So they are allowed to do 100 tests at random. They also get the test kits, they take the test kits, and at the field level, they do water testing, 100 tests in a month, each Jal Sathi. Facilitating consumer complaint redressal, that is most important. Apart from the 24/7 call center and IVR system that we have there in system. Then the next, so next is leaping forward to higher bit, drink from tap mission. So when we achieved 100% household connection, when we achieved metering, then we thought we should go to the drink from tap mission. Without achieving 100% house connection, so this drink from tap mission is not, should not be dreamt for. So assure drinking water quality supply at the consumer taps with 24/7 with 100% meter connections, saving of household level investment on house level storage, daily pumping, treatment, etc. This is not required. Reduce water losses, NRW with real-time monitoring. So this real-time monitoring is very important feature of DFT. That could be everywhere, because wherever there is, because everything is automated, there is seamless communication. I told you, if there is any problem at the distribution system, at the failure of breakage of pipeline, damage of pipeline, or anything, so immediately that signal comes to the PLC. The PLC gives the signal, gives the command, and the valve is automatically closed. So water losses is stopped, and quick response team rushes to the spot for attending the repair. So this smart water management is very important for reducing NRW, apart from water quality. So, then we get it, all the data from the PLC. Suppose in a Puri have 19 DMH, 19 PLCs. So Berhampur has 26 DMH, 26 PLCs. Bhubaneswar is will having 137 DMH, 137 PLCs. All these PLC data from these PLCs are communicated to a city level server. Each city has a city level server, and from the city level server, it comes to our integrated command center to the main Watco building where I am sitting. So I can see what is happening in Puri, what is happening in each city from here. What is the pressure of a DMA of Berhampur town or Puri town? What is the residual chlorine now at the DMA of Puri? I can see here from my head office. So these are all interconnected through city level servers. So communication from the city level, from the PLC to the city level server, it is something difficult, because it is because the PLC all over whatever the precision instruments I have discussed earlier, they are all machines. So they communicate with each other in machine language. Whenever I want to communicate it from the PLC to the server, server is a computer. So this machine language is to become more converted to the computer language. So that is the problematic part of the smart water management system. Then you see digital water meter with real-time collection analysis with command control, real-time flow, pressure management, repair management, complaint redressal, etc. And we are displaying digital distributors. You see the picture at strategic points. Apart from our own viewing in the website, in our site, but we also display in a DMA what is the pressure, what is the quality turbidity, what is the residual pressure. So at strategic location of the DMA, the digital display boards are there. So for displaying the water quality for the knowledge of the public. So we have a state-of-art laboratories at region level on PPP mode. Online residual chlorine analyzers, I have already told, in the network, and automatic chlorine dosing system is active. You see, key features is reduced response time from weeks to few hours. The response time is very important for reduction of NRW. Reduce NRW, consistent pressure and flow ensured, data collection with remote command and control. GIS mapping, assets consumers, I have already told. Lane by lane level sensors, I have already discussed on this. 24/7 customer care, resolving water issues, I have already discussed. Quick response team, I have discussed, and lab on which I have already discussed. You see, this is important because I have time. I have no time. The challenges and learnings. The challenges are that, you see, ensuring water quality at the consumer end is a challenge. And you see, this intervention made was intermediate to 24/7 water supply, online residual chlorine analysis, and real-time chlorine dosing, state-of-the-art laboratories on PPP mode, lab on wheels, deployed to ensure quality test at the consumer point, water quality indicator tests by Jalsati in the field. Non-availability of information on infrastructure assets and consumers, GIS based asset mapping and consumer mapping, I have discussed. Inadequate human resources and competencies, the Jalsati partnership establishment of Odisha Water Academy, now Odisha Urban Academy. Then challenges and learnings, absence of community connect, lack of public confidence and trust, deployment of Jalsati partnership, digital display boards in public places, real-time water quality data PA4CR campaign, that is ISC campaign. Delay in grievance redressal. Now we have 24/7 IVRS customer care, quick response teams, and real-time tracking of complaint redressal. Then the challenge is that very high non-revenue water, it was more than 50%. So large-scale illegal connection, sucking of water by individual pumps, depriving pressure talents. That was the scenario, that was the challenge. So intervention made was the digital water management, dedicated NRW cell, training, certification, and employment of plumbers, saddle and compression fitting in the ferrule points of house connections, Jalsati partnership, each of new connections intermediate to 24/7 water supply. You see. Next, this consumer perception. So we had left side, that consumer perception, independent impact assessment study was conducted by NIWA MOA. So in that time, it was done 1.5 years back or more than that. Now another impact study is being done for 8 cities. At that time, 79% were directly drinking from the tap in Bhubaneswar, pilot zones, and 80% directly were drinking from the Puri. And you see the impact on public health, which is prime importance, for which we are here, for which we are discussing, for which DFT concept came. You see the reported jaundice cases from 2029 to 2022. This data has come from the health department. There is no reported jaundice cases. So jaundice has been removed by this in the DFT areas. And also in the diarrheal cases also has been reduced substantially in 2021. This is health department and the entire state figure. 4 cases were reported from the rural areas and not from the urban areas. So what are the myth and what is the truth? You see, the myth is that increase in water demand. People think that by providing 24/7 water supply will increase water demand. That is not the fact. Demand went initially, but stabilized soon and remained constant. Impact of communication of Jalsati's opportunity of metering and revenue collection was there. So that means in 24/7 water supply, increase of quantity of water supply will not happen. Rather, it will be within 15%. NRW will come within 15%, and consumption will be the total quantity of supply will reduce. Increase in water leakages and wastage. That was the myth, but the truth is that NRW non-revenue water reduced from 50% to 15% in the DFT areas. The myth is that high operation and maintenance cost. The truth is that almost same O&M cost as intermittent supply, energy cost decreased due to load NRW. High capital cost, that was the myth. So the cost is not much, it was 2,000, but it varies from town to town. So huge manpower required, that was the myth. No additional manpower taken, also the field of the gap. The myth was high and external experts are required. So it's not truth. 100% skilled, built, made in Odisha, in-house engineers and local contractors. We have not taken help of any big contractors or any experts from outside. It is inbuilt, home built. Then the myth was that revenue recovery is doubtful, but in 24/7 water supply, 90% collection efficiency or more in DFT areas. And we have established an Odisha Water Academy, which has been upgraded to Odisha Urban Academy. So towards creating skilled workforce. So founded in 2021, upgraded in 2023, customized training modules for plumbers, operators, Jalsati, supervisors, engineers, managers, and police makers. About more than 3,500 professionals have been trained by Odisha Urban Academy till now. You see, we got the PMC contract from Chennai government for area 10 and 13 of Chennai city. This is the agreement signing ceremony. So my additional chief secretary and I am standing there behind near the ministers. So then the path followed. This is the path followed is that mission mode approach, enabling policy measures, infrastructure drive, then including the building team and capacity upgradation, including local contractors, institutional reforms, creation of WATCO, community partnership with Jalsati, universal coverage with 100% house connection, 100% metering. Then it converted to 24/7 tap. As a result, NRW was reduced, revenue collection was increased. So we WATCO bagged World Water Leader Award in 2022. So next, the key takeaways. The key takeaways are that political commitment is the key. Public drinking water supply is not only a purely engineering service, it is a socio engineering. Be flexible to rewrite policy wherever it is required. Onboarding of community is key to long-term success. Continuous technology orientation and skilling, leadership, teamwork, and speed of decision making at all levels is critical. So, thank you. I just skipped many things. So I should have elaborated many things, but due to constraint of time, and you, as you know, I have a meeting with Chief Secretary at 5:30, so I have to skip and be speedier. So I conclude my session here. So if any question is there, please, I can afford another 10-15 minutes for answering the questions.
Thank you very much, Sohan sir. Any questions you can directly ask since he has a very short of time. So be precise on his questions. Please go ahead asking questions or raise hand.
Good evening, sir. I am Raghavendra, retired Chief Engineer from Karnataka Urban Water Supply and advisor to Rural Drinking Water and Sanitation Department. I am a very specific question. Out of this 27 towns, any city is on real time on web?
I am not audible. Please repeat.
Out of this 26 or 27 towns, any city is on real time on web.
You see, not 26, it's 24 cities.
Okay, fine.
Not 24 cities.
Sure.
All the DMAs are real time monitoring.
You are monitoring whether it is available on web links so that we can see it.
It is monitoring not for public viewing. It is for us. If you can come, we can show you here, but we cannot give the access to you.
Okay, thank you.
Sir, me IC Jain, retired Chief Engineer, PhD. What step you have taken to reduce NRW from 50% to 15% only? What was the water demand at the rate of 50% NRW and now 15%? Can you explain?
Definitely. You see, if you take decisive steps, you see, the step is that previously the household connection was the culprit. Our learning was that in household connections, because you insert a ferrule to a pipeline by puncturing the pipeline, and ferrule has an outside thread and thickness of the pipe is very less, so it does not get tight. So while backfilling, by tilting by sway action, there is some gap. So drop by drop, drop by drop, drop by drop, enormous quantity of water is lost there. So we replaced it with compression fittings and saddles. So that reduced. Then the smart water management reduced NRW. So when the demand, you see, the 135 electricity plus 50% was the demand. Now 135 electricity plus 15% is demand.
No. Have you changed the pipe material? Like you have put
No.
PVC or
Pipe material is not. I have told initially asset mapping, consumer mapping, condition assessment. After condition assessment, wherever the pipe is damaged or required to be changed, that has been changed. That is almost 10%. 10% pipes have to be changed. 10 to 12% pipes have to be changed.
Okay.
Yeah, can I ask, please?
Yes.
Yeah, good afternoon, sir. My name is Dr. Shivaram. I am former professor and head from National Institute of Rural Development and Panchayat Raj, Hyderabad. And this drink from tap mission is wonderful. And I must appreciate 24/7. And I must congratulate for your wonderful presentation.
Thank
I
you.
have only one question. How many liters are fixed per capita per day?
How many
liters of drinking water or water fixed for per capita per day?
You see, that has been fixed by the CPHO manual. You see, in CPHO manual previously it was 135 electricity per capita per day for these cities. But
Yeah.
now they have described that the mega cities, in mega cities, the per capita is 150 LPCD. And in which are mega cities, they have defined the cities having population more than 10 lakhs. So the cities having population more than 10 lakhs, the per capita is
Excellent, sir.
150.
Excellent. You said that 150 liters of water per capita per day is fixed. Are you really giving that 150 liters of water per capita per day, please?
So in Bhubaneswar, we are giving 270 liters per capita per day.
Oh, excellent. What about summer?
In summer, this is in summer. In summer,
Yeah.
we are giving 270 in Bhubaneswar, not in other cities. Other cities we are giving, because other cities the population is less than 10 lakhs, we are giving wherever one giving 140, 146, 150 like that, or 135. So other cities. But in Bhubaneswar, because it is capital city and there is no depth of water, we have a good many of rivers. River Mahanadi, River Katajodi, so many rivers are surrounded. So here the supply position is much better.
Yeah, sources are from surface water only.
All surface sources. We advocate for surface sources. In one
Yeah,
city in one city out of 24 cities, we have gone for DFT from groundwater, but now subsequently we are changing it to surface water.
Yeah, thank you, sir. Thank you so much.
Sir, recently I visited Orissa, Balasore district. There, water supply based on groundwater tube wells only. And that too, they were drying in the summertime.
You see, Baleswar is not under WATCO and this is not also DFT. This is intermediate water supply and being maintained by some other agency, not by WATCO.
JJM Puduseri is waiting to JJM Puduseri is waiting for some question. JJM Puduseri.
Yes, sir. Sir,
JJM Puducherry, please.
Sir, good afternoon, sir. Sir, JJM Puducherry, sir. Sir, here our district is completely critically water stressed, sir, and so we are fully depends upon groundwater, sir. It is able to implement 20.7, sir. It is available sources.
Mr. Din Jalani has joined as Chief Engineer of Puducherry.
Yes, sir.
So a team of 7 to 8 engineers are going to coming here to see Puri on 26th, 27th, as he has told me. So they can see Puri and how it is working. They can see in Puri and Bhubaneswar. And from groundwater also, you can go for DFT. But the thing is that the adequacy of groundwater should be there. There should be adequate quantity of groundwater.
We are fully depends upon groundwater, sir.
Yes. If source sustainability of groundwater, if the perspective of groundwater is very positive, if there is the basin is quite recharged, and if your requirement can be filled up from the groundwater, no problem. No problem.
Okay.
Thank you. Please excuse me. Just now 1:20. कितना हुआ?
Rashtrapati.
So please, I am leaving. Any question you can send in my mail. My mail is with the organizers. You put your questions, send through mail. I will give the reply.
Thank you very much, sir. Yes,
please, sir. Now, please carry on, sir.
Shankar
sir, please carry on for vote of thanks.
Yeah, we are very much thankful to Sohain sir for his very informative and very interesting presentation. I hope that all the participants got benefited from him, and we hope that one day all state of our country will see this initiative. Thank you very much to all the participants. And this is for the knowledge of our participants that we are going live stream in YouTube also. Today there is some little bit of technical error, but now onwards you can enjoy all the broadcast in YouTube channel also. So thank you very much for support our advisors, sir, please.
Sekia sir, please share the PPT in the chat box as a file so that all the participants who have joined can download the PPT. There is a facility in the WebEx you can share the file in the chat box and link of the YouTube channel also. Thank you.
Okay, sir. Okay, sir. Now, PPT is right now. PPT is not with me. I'll get it from Schweitzer and will share. Thank you.
Once the meeting is closed, then you will not be able to share it. You
Okay,
have to
sir.
share it before the closure of the meeting. Okay. So so who has showed the PPT from their office only?
Sir?
Who has shared the PPT?
PPT is shared with Schweitzer, sir.
So then
Yes, sir.
you will do. Okay. But in future, please get the PPT in advance. Arupji, please always ensure that PPT is with us in advance so that we can share participants.
Sure.
So today,
Next,
are
I'll
we
take care of
able
that.
to live telecast the program at YouTube or not? Seke sir, were we able to live stream the program at YouTube today or not?
No, it was streaming live, sir. But the picture is distorting today for some technical reason, maybe. So it was live. It was live, but that screen was distorting somehow.
Then,
so we have to look after that.
Carry out some testing tomorrow in the
Yes.
Train your staff so that we are able to share all the content on the YouTube. So अरूप जी थोड़ा इस पे बैकग्राउंड में काम कर लीजिए इन चीजों पे ये बड़ी ये क्योंकि
I'm giving the link about this YouTube channel here.
Even Vaikas Singh was also demanding the link for the YouTube. I told him that we have live streamed the PPT and the deliberation at the YouTube channel. So he was interested to share the link with him so that he can see and watch the video at YouTube channel tonight. So whatever we had done, please share the link with him also. अरूप जी हमसे आप शेयर कर लीजिए इसका YouTube का लिंक का चैनल.
ठीक है.
Thank you.
Yes, I have shared this YouTube channel in the short box.
Okay, and share with the Director JJM Vaikas Singh ji also. Arup ji have his mobile number. Please share with him also. Okay.
So I think we can conclude it right now. Thank you very much all for joining us, and we shall be meeting again on 28th of May, with a new chapter. Thank you.